Hey guys, I'm here to do lesson 6.14 with you. Your learning target for today's lesson is I will be able to simplify expressions. Let's dig into your think about it. It says Angela drew a regular octagon. A regular octagon means that all the sides are the same length. And don't forget, an octagon has 8 sides. Okay? So Angela drew a regular octagon with a side length of 3p plus 2. Write 2 equivalent expressions that represent the perimeter of the octagon. Explain how you know that the expressions that you wrote are equivalent. So before I send you off to do your think about it, let's remember that perimeter is the distance around the shape. Okay, so the definition of perimeter is the distance around the shape. In this case, it would be an octagon. So go ahead and pause the video and see if you can work it out on your own. Alright guys, hopefully you paused it. So I'm going to give you a bunch of different possibilities that maybe you came up with. There's 3 possible expressions that you would come up with. Let's start with the easiest one. So the first possible one, oops, I need to switch to my pencil. This one's going to take a minute to write. And we know that the distance is 3p plus 2 for each side, then we can add 3p plus 2 8 times. So I'm going to start writing out groups of 3p plus 2, and I need to do it 8 times. So bear with me. Let's double check I did that correct. We have 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So on this expression, what we did is we added up all of the sides. Now, we could readjust this whole expression and make sure that we combine our like terms. So if we bring all the 3 p's to one side of the expression and then move all of the 2's to the other side of the expression and we combine them all, we'd get our second possible expression, which is 24p plus 2. So if I add up all those 3 p's, I get 24 of them. And if I, oops, I'm sorry, it's not plus 2, it's plus 16. Okay, and if I add up all of the 2's, I get a total of 16. So here, we combined all of the like terms. Our plus 2's all ended up being 16 once we added them all together. And then all of our 3 p's ended up being 24p when we added them all together. Okay, there's one more possible answer you could have came up with. And that is where, since we have 8 possible sides on this octagon, we're going to take 8 and multiply that by the side length, which is 3 plus 2. So here, we know that repeated addition is multiplication. Okay, so from the original expression, we saw that we added it up 8 times. And a faster way of getting there than adding it up 8 times individually is just multiplying 8 times that one sum, which was 3p plus 2. Okay, so on this one, we also have 8 groups of our side length, which was 3p plus 2. So now which one of these do you think is the simplest terms? Because one of these 3 expressions is in the simplest term. So the one with the simplest term is number 2. Okay, we actually also applied the distributive property to get here. So not only could we have added the like terms, but if we go from expression 3 to expression 2, notice we can distribute our 8. And when we distribute it, it multiplies. So 8 times 3p gives us 24p, plus 8 times 2 gives us 16. So we also apply the distributive property on this one. So the simplest term is this one. And that's because we can't simplify it anymore. We cannot combine 24p and 16 because those are not like terms. I can't apply any other number property like the commutative property or associative property to make this any easier. So that's how we know this is the simplest form or simplest term. Simplest term is always going to be the one where once you have to substitute, it's going to be less work because it's faster. Okay, it's the simplest. So let's go ahead and move on. Jumping into a little geometry here, we have our Tesla conjecture. Looks like we're going to have to write a expression for the perimeter of that triangle. But let's look at our conjecture that we're testing. Our conjecture says that properties can be applied to create simpler equivalent expressions. So that's what we're going to be testing today. So Tesla conjecture number 1 says, write an expression that represents the perimeter of the isosceles triangle in simplest form. So remember, perimeter is just the distance around the shape. We've already talked about that with our think about it. So we can come up with 2 possible expressions for this one as well. Okay, so I'm going to do one on the left and one on the right. So one expression that we can come up with is we can take these terms and add them all together. Okay, so we have 3x plus 2 plus 3x plus 2 plus 8.5. Okay, on the other side, well, I notice that there's 2 of these 3x plus 2 groups. So I know that I can multiply 2 times 3x plus 2 and then add our 8.5. So what I'm going to do is I'm going to show you that once we combine like terms, these 2 expressions will end up being equivalent expressions. Then we'll check our work by substituting in a value for our variable. So I'm going to do this on the left-hand side. I'm going to put all the like terms together. I'm going to use the commutative property and move these like terms. So we have 3x, 3x, those are like terms. And then we have positive 2, and then positive 8.5. So I'm going to move my expression so that those like terms are together. So we have 3x plus 3x plus 2 plus 2 plus 8.5. And if I simplify this even further, I can combine these terms. So 3x plus 3x, well 3 plus 3 is 6. So we have 6x, okay? Then we have 2 plus 2, which we know is 4, and then we're still going to have to add 8.5. I still have some like terms, these constants here, so I have to add 4 plus 8.5, and that gives us 12.5. And we bring down our 6. So we've got 6x plus 12.5 is the simplest term there. So let's check our expression on the right-hand side now. So for this one, I would be applying the distributive property. Okay, I have to distribute the 2 to this sum. So 2 times 3x plus 2 times 4, 2 times 2, because I would reload and then distribute that 2 again, and then I have to add 8.5. Okay, so 2 times 3x would be 6x plus 2 times 2 is 4 plus 8.5. Still have some constants that I can combine, so 4 plus 8.5 is 12.5, and then we add our 6x. So if you notice, we have come down to the same expression for each of these beginning expressions that we had. Okay, so what I'm going to do is I'm going to pick just one of these expressions. I think I'll pick expression number 2, and we're going to check some work. We're going to check to see that if I plug in a value for x, that this expression is going to be equivalent to this expression, just to prove that they are equivalent. So let's do some checking. Okay, we're going to say x is going to equal 2 because, you know, it's my favorite number to use. It's really easy. So let's plug it in for the original one, which is this first one. So we have 2, 3 times x, which is 2, plus 2, plus 8.5. Okay, so using the order of operations, we have to simplify inside our parentheses first. So we have 3 times 2, which is 6, plus 2. Bring everything else down. Okay, I'm still applying the order of operations, so I have to do 6 plus 2 first. 6 plus 2 is 8. Bring everything else down. Okay, 2 times 8 is 16, plus 8.5 gives us a final answer of 24.5. So now let's plug it into our second expression, the most simplified one. So we have 6 times x, which was 2, plus 12.5. So order of operations says we have to do multiplication first. 6 times 2 is 12, plus 12.5. One more step, we have to add 12 plus 12.5, and that gives us 24.5, which is the same answer. So we did just prove that this expression is equivalent to this expression. Notice how much simpler it was to use this expression, the more simplified version. Like I said, simplified makes your life easier. Why work harder when you can work smarter? That's my favorite motto. All right, guys, let's do test the conjecture number 2. So we have to simplify the expression. I'm going to go ahead and rewrite that down here. It looks like we're going to have to apply the distributive property here. All right, so let's go ahead and distribute our 4. So we have 4 times 9n, so 4 times 9n minus, distribute again, 4 times 2.5, and then we have to add 3.75. Okay, so let's simplify here. First we have 4 times n, which is 36. I'm sorry, 4 times 9n, which is 36n. Okay, we have 4 times 2.5, which 4 times 2.5 is actually 10. And then we have to add the 3.75. So remember, when we're combining like terms, we have to take our symbols with it. So we do have 2 constants still, and those are like terms. But pay attention here because we have our negative 10 to start with. So if we have negative 10 and we add 3.75, that gives us 6.25. So here is our most simplified version of the expression above. Okay, it's really important here because if I had just done 10, positive 10, plus 3.75, I would have gotten 13.75, which is very different than the 6.25 that we got. Okay, so it's really important that when we're combining like terms, we really pay attention to the symbols that are in front of them as well. Okay, so now all we have to do is check to make sure our expressions are equivalent. So we're going to first substitute a variable in on that expression and then on our final one. So let's do our check. Okay, let's say that n equals 2. So let's do our first expression. We have 4, 9 times 2 minus 2.5 and then plus 3.75. Okay, so we have 9 times 2, which is 18, minus 2.5, bring down the rest of this. Okay, 18 minus 2.5 would be 15.5. 4 times 15.5 is 62, plus 3.75 gives us an answer of 65.75. Okay, so now let's see if when we plug in to the bottom expression, if we still get the same answer. So we have 36n, which n is 2, minus 6.25. So 36 times 2 is 72 minus 6.25, and 72 minus 6.25 is 65.75. So we did get equivalent expressions. So our conjecture stated that properties can be applied to create simpler equivalent expressions. That is very true. On test the conjecture number 1, we applied 2 different properties. Here on number 1, we applied the commutative. We grouped those like terms and then added them together. We combined them. On number 2, we did the distributive property. And finally, on test the conjecture number 2, we also applied the distributive property. So properties can be applied to create simpler equivalent expressions. This is true.